I see a lot of job postings for full stack developer. And a full stack developer is supposed to be this person who knows everything from the front end to the back end. And there's always kind of a tug of war between the idea that we need a full stack developer and a DevOps team. And there's problems with both of these because, spoiler, one person can't know everything. It's just too many moving parts. But at the same time, we often have DevOps teams who don't understand how much is involved in each area of this full stack of development. So I want to go through very quickly what I consider the primary areas of full stack development. And if you think about things like the front end, which is the bit that you're looking at right now, when you're looking at a website or you're getting a video or something like that, but it comes through networking to get to that browser, and it's being hosted somewhere, processing on cloud computing. And of course, there's data being stored persistently out in some sort of database. It seems like, well, there's just, 4 things to do there. But honestly, when you really look at this, in the front end, just the basics, HTML, CSS, and JavaScript. You're going to have to make this thing work just from lightweight code, but then you're going to have a responsive design so that you understand when someone's looking at it on a tablet or a mobile phone, or they turn that mobile phone sideways. How is that going to look? And then there's going to be different behavior on different browsers because we don't just code for Chrome. We have to think about Safari and Firefox and maybe Edge and maybe Opera, but all of these different browsers do behave differently. And the browser can store data. So we have to think about how we store that data. Do we keep it persistent? Does it die in the session? Does it stay forever? Do we have large limits? And what does it look like? So there's data modeling. And some of that data lives in an API that you're going to have to reach out to, which means you have keys you have to manage. You have security keys that have to be stored in a way that you can access that. And I haven't even talked about making it pretty, doing things with Adobe tools and graphics and, where is all that going to come from? And then you might have to change it for different countries, even if it's all in English, localizing for England versus localizing for the United States are different flavors. And then we also have things like accessibility. Is somebody going to be able to use tools for vision impairment? And are you going to be able to make it higher contrast and things like that? This is a lot of stuff just to make the front end. We haven't even gotten to things like how does that front end talk to the back end? And to do that, you're going to have to start dealing with all your networking rules. You're going to have to establish your DNS, which DNS is your name service. If you want to do www.myproject.whatever, great. Except then you have to start dealing with load balancing and gateways, because if you're going to scale, you're going to have multiple places that goes, and how you're going to handle that. And that load balancing, of course, can also do things like caching. So some of that content isn't going all the way to the back end, but is actually kind of existing in the network itself. And as you do that, you have to start thinking about your headers that are in the HTTP. And this is getting down into nitty-gritty networking details, but you don't always want to pass all those headers all the way to the back, or you don't want to expose all the headers from the back end all the way to the front. And how does that work in a CDN, which is a content delivery network, where you may be sharing an original piece of copy with multiple people? Now, you also then leave the world of routable DNS into your virtual computing, where you have private clouds. And that has an entirely different set of IP addresses and things like that, where you have firewalls and you have to route it, and then you have to deal with what ports you're going to have open. And then all of this can add up to it being slow. And the question is, where is it slow? And then this opens things up to where people might be able to sneak in somewhere in this whole chain. And then how do you know that? And how do you alert it? And how do you stop it when that happens? Of course, the network is just how you get places. When you get there itself, we're talking about the cloud, and you're going to have servers that you're going to have to size. Now, maybe that's going to be an individual EC2 instance that acts like an old school server, or maybe it's going to be something like Lambda services or other things. But you're going to have to worry about how those scale. You're going to have to worry about how you're deploying your code to those, and that you have the best practices to have the most current code as you're moving forward. And then if you're getting into things like Docker and Kubernetes, that's a whole entire different set of disciplines. But regardless, you're going to have dependencies and different kinds of applications and different kinds of modules, and there are going to be vulnerabilities that you may inherit with that. You're going to have to maintain and patch all of that. You're going to have certificates that are going to be constantly updated, but also say, I am the service that you think I am. And then how are you going to deploy those and manage those? And of course, again, you're going to have monitoring, you're going to have alerts, you're going to have escalation, you're going to have issues that you're going to have to deal with. And when you deal with them, how does it fail over? How do you get a new instance up and running? And finally, we have the back-end data. And of course, data modeling, we can't just throw data in there and expect it to grow and change. We have to understand what the data looks like in order to choose the right data platform that we're going to use in the first place. And then as that data grows and changes, we're going to have to understand what's being written, what's being read, so we can make it run quickly. We have to think about what we do with large objects like video files that you're not necessarily going to shove into a database, but how do you integrate that into your flow? And again, scaling. And I'm talking sizing scaling at this point, because you can always make a database bigger, but as you start to grow, maybe you need to get rid of some of that and then bring the size back down, which is a discipline unto itself once again. And migrating from one environment, understanding where you're caching, how you're backing up and restoring, how you're going to clean up all that data, and then who gets access. So this is a lot. There's a lot for one person to understand. It's a lot for somebody, for example, the data area to be able to understand what somebody's doing in the front end, or for somebody on networking to understand what's going on in cloud. All of these are different disciplines, and you need to respect that people may know more about different parts of it than you. And even once you have all these technical things, this technical laundry list of things that have to happen, you still have to deal with things like accounting. All this costs money, and you want to make sure you're not having accounting cost overruns. You need to make sure that you're legally in compliance with the laws that apply to where you are. And remember, the internet isn't necessarily a single place where you are. You may find yourself having to comply with European law in the United States because you're delivering content to the EU. You have to think about security, which is something I talk about all the time, but the security is something that weaves through all of this. And then the business requirements have to be articulated and followed. And that idea of taking a business requirement and turning it into a technical deliverable for these different areas becomes a bit complicated. You've got to set service level agreements so that people understand when you're going to be up and when you're going to be down. And then, of course, you need identity to tie it all together. And these are all different kinds of business and technical requirements that you need in order to be successful with a web application that's going to survive in the real world. So, obviously, you need a full stack team. Less obviously, this team needs to be able to understand what the other members of the team are doing. And it all needs to be tied together with business practices and things that are non-technical, but drive this entire environment that we call full stack development.